This video features the Freeburg Early Childhood Program, operated by the Regents Center for Early Developmental Education at the University of Northern Iowa. The Freeburg Early Childhood Program serves children from 3 to 7 years of age in McElroy Hall on the Allen College campus in Waterloo, Iowa. This video was made possible by a grant from the U.S. Department of Education. Children at the Freeburg Early Childhood Program enjoy experimenting with ramps and pathways. These activities are beneficial because they promote the development of reasoning and knowledge about the physical world. They fall in the category of physical knowledge activities, in which children act on objects and observe the results of their actions. As children work with ramps, they construct knowledge about what can be done with the objects along with knowledge of the object's properties. There are two types of physical knowledge activities: those that involve movement of objects, or physics of mechanics, and those that involve changes in objects, or chemistry. Ramps and pathways fall in the category of movement of objects. Children learn about the physics of ramps by experimenting, making mistakes, encountering contradictions to their expectations, and trying again. This process of error-informed experimentation is the foundation for the construction of knowledge and intelligence. In good physical knowledge activities, children must be able to produce what happens through their own actions. The result must be immediate so that they can connect the result with their actions. Children must be able to observe what happens and be able to vary their actions in order to produce and observe varying results. Physical knowledge activities provide opportunities for children to figure out how to do something.
I was using the gutters in the play yard, and my gutter was at a steep incline and hers was relatively flat. And we were shoveling pea gravel off the play yard and putting it down the gutters. Mine was running very rapidly and hers was just barely trickling. And she would watch mine and she would look at hers, and pretty soon she said to me, "Can I use your shovel?" So I gave her my shovel and picked up another shovel, and she tried my shovel, and the gravel still didn't move very rapidly on hers, and in the meantime mine was still going down quite rapidly. So she looked at me again and said, "Can I use your shovel?"
This anecdote illustrates a child's pre-operational reasoning about a physical event whose cause is not immediately understood. The child appears to believe that the teacher's shovel caused the pea gravel to move down the ramp quickly. When she uses the teacher's shovel on her own gutter, the result is the same as before. The gravel does not move. This creates a feeling of contradiction between what she expects and what she sees. Further experimentation over time leads her to revise her ideas. Good physical knowledge materials inspire children to experiment in many different ways and allow for endless possibilities. Most of the materials used in this video are cove molding cut into units of 1 foot to 4 foot lengths and objects for moving down the ramps. Marbles of different sizes move easily down cove molding ramps. For young children, use marbles that will not go down a choke tube. Older children who no longer mouth objects can use a variety of sizes. The size variable allows children to make comparisons between the reactions of large and small marbles.
Jamie, can you roll a small sphere down to show us what happens when you roll a small sphere?
Other objects that children can compare include microcars, balls, objects that do not roll, such as cubes, and objects that roll differently. When propping up ramps, children often use whatever is convenient as supports, such as shelves, chairs, tables, wooden unit blocks, large cardboard blocks, and oversized interlocking blocks. An assistant teacher in kindergarten created another type of support that enables children to vary the ramp height easily.
These are some boxes, and I made these because I was wondering if there was any way you could use these boxes when making ramps. When I saw this box, it came to my mind that this would be a good box for ramps. And I had an idea about cutting holes in the box to offer more varied heights of starting points for the ramps. And also, some of the structures, sometimes they would fall down, and I could see frustration on some of the kids' faces. So I thought, well, the box is sturdy, and if they would place a ramp into one of the slits, then they'd have more control of where they wanted their marbles to go.
Constructivist teachers plan, organize, and implement activities so that children will have the opportunity to make mental relationships, that is, the mental linking of variables, such as slope and movement of objects. When connecting ramp segments, children tend to add the second segment so that it overlaps the first. This child expects her car to roll to the end of the ramp. She has formed a mental relationship between the slope of the ramp and the expected continuous movement of the car. However, she aligns the segments without considering the effect of the ramp overlap. Her surprise when the car hits the overlap and stops indicates a feeling of contradiction between her expectation and what happened. This motivates the child to revise her previous relationship and correct the overlap. 10 principles guide the teacher in promoting children's experimentation and learning. Constructivist teachers experiment with materials to understand the relationships involved. Before introducing ramps and pathways materials to children, it is important for teachers to experiment with the materials themselves. This will allow teachers to become familiar with the kinds of problems children may encounter when using ramps, as well as the possible relationships that children can construct.
This one won. Why did ours come down back? Yours was slower than ours. Why is that?
Because yours is, you have one,
Yeah, you
two,
have more
three,
elevations.
four. You start out on 1, 2, 3, 4, 5. You start out on 6, and we start out on 4.
Put you 2 more and let's try it again. Yeah.
That's the relationship between that number of blocks on that end and this
What's the
number of blocks.
relationship?
The relationship between
Speed and the number of blocks?
the number of blocks on one end and the number of blocks
and
on
how
the other.
fast the
and
marble
how,
travels.
That's right.
Constructivist teachers introduce materials to children to stimulate interest and experimentation.
There's a couple different ways that I introduce ramps for the first time. Sometimes I introduce it at group time, and sometimes I introduce them at activity time. If I introduce them at group time, one way is simply to put a ramp flat on the floor and put a marble on it and ask children how we might get the object to move along the groove in the ramp. Does anybody have any ideas how you could get the marble to move from here to here? Or from here to there?
I know how to here to here.
How would you do it?
This.
You can do it with your finger, can't you, and make it move? Okay. And then as children have ideas, I ask them to come and demonstrate. And when children start to have many ideas, I simply say, you know, we're going to have these out during activity time. You might try out your ideas then. If I'm going to introduce it at activity time, I simply put the materials out and let the children begin to experiment. If none of the children try making ramps out of them, then I might go and start to play. When I want children to start an activity, I find that if I go there myself and start working with it, that children come and join me.
I use the ramps on the table for an introduction. I think getting it in a small confined space with the shorter ramps helps the children to focus on what is actually happening with the incline and the marble or the ball or whatever they're using. So I always introduce it this way. However, interest doesn't stay a long time on this small scale, and then I graduate to the larger ramps on the floor.
When cove molding is presented to children as ramps, children tend to think of them only as ramps and usually use them safely. Some teachers prefer to discuss safety issues only if problems arise. Others discuss safety when introducing the materials. Constructivist teachers create an environment that inspires children to have ideas and figure out how to do something. Good materials attract children and invite exploration. When children have adequate space and ample materials, they become highly engaged and have many ideas about how to use them. When ramps materials are always available, children continue to invent more and more complex problems for many years. Constructivist teachers allow children to try out their ideas.
Children try things because they believe they will work.
Where are you going to put it? Going to move it out?
If we tell them that they won't work, they will begin not to trust their own reasoning.
What can you do so it'll catch it? What can you do so it'll catch it? What can you do?
Just behind you. Later.
Put it out there, you think? Okay, give it a try again.
She has constructed a misconception that when the marble rolls down off the ramp, that it will drop straight down. If we tell her she's wrong, she will lose confidence in herself and she will learn not to trust her own ideas. It's the teacher's job to set up the environment so that she will learn from the materials that her ideas won't work, not from another person. The children are working at cross purposes. He has constructed the relationship that it will go down and arc, and so he continues to put the basket out where he thinks it will catch. She, on the other hand, is constructing different relationships because she continues to put it very close to the bottom for it to drop straight down.
Jamel, can you push it to where you think it'll go so they'll fall in from there?
They need to try out their ideas so that their internal beliefs about what will work and what will not work will change. They can't do that without the experimentation.
When teachers allow children the freedom to try out their own ideas, children soon become interested in setting problems for themselves. The child in the circle attempts to build a ramp that empties into a container. As you watch him, you will see the process of the construction of knowledge. At this point, he has not yet constructed the relationship between the slope of the ramp and the direction the ball will roll. Although he expects the ball to roll toward the container, it continues to roll down the slope toward the sponges. He appears to think that there is something about the highlighted end that causes the ball to roll toward it. Unaware of the slope, he turns the ramp around as if this will cause the ball to roll into the container. The process of experimentation continues as he adds a sponge to the support and tries again. Observing the ball still rolling away from the container, he varies his action again by adding more sponges to the support, thereby changing the slope. Once again, he places the ball on the ramp and finally succeeds. Had the teacher solved the problem for him, it would have robbed him of this aha moment. He is making progress in constructing the relationship between the slope of the ramp and the direction the ball rolls. Children create highly complex structures only after long experiences constructing relationships about slopes, supports, connections, and other elements of pathway design. When this child was challenged to create a structure within a taped-off area on the rug, she drew upon her prior knowledge of all of these relationships. She used this knowledge to take into account the need for each corner to drop so that the marble would continue downward on the spiraling pathway. She coordinated many relationships and was able to think about the system as a whole. Constructivist teachers observe children's actions to understand and assess their reasoning.
I could see that he had something in mind as I approached that experience that he was having with his ramps that day. He had a lot of interest in ramps, and so I really wanted to see where he was going. My questions then became questions that didn't direct but supported. I was writing down what I was seeing him do. That way I could see how he's growing in his knowledge of this activity.
Constructivist teachers intervene with questions and comments to encourage children's reasoning. This university student purposely set up the ramp so these 3-year-olds would encounter a problem and have an opportunity to figure out a solution. She created a slight gap between the first and second ramp segments, which would stop the ball's movement on the pathway. Unable to get the ball to roll across the connection between the ramp segments, the child hypothesizes that the problem is the ball and tries another.
Sure. We need another ball.
We need another ball?
Yeah.
Okay.
We need to.
The teacher then poses a question to encourage the child's continued engagement in the activity.
How can we get it like this one?
A dog. And then you make different colors.
Prompted by the teacher's question, the child readjusts the connection between the ramp segments. When her attempt fails again, she bypasses the connection and places the ball onto the second ramp segment, demonstrating that she has not yet constructed a relationship between the placement of the ramp segments and the continuous movement of the ball. Questions or comments can be used to focus children's thinking and their actions on a particular problem.
Okay, so look at where there's a problem.
I told you. Give me a ball.
I noticed it right here, right
This one
here.
almost went.
Look, guys, right here, this is where the marble is coming off. So what do you need to do there to make the marble continue?
I know. Oh! Good try, Brady. Almost did it.
Constructivist teachers do not pursue an intervention when a child has a different idea. Sometimes a teacher's question or comment does not fit with a child's purpose.
Would it make a difference if you switch the boxes around? If you have the higher box on that end, you think that would make a difference? The taller box?
When the child does not respond, the constructivist teacher respects the child's agenda and backs off. Constructivist teachers support children's representations and discussions of their ideas.
If you have a good community, the children are going to respect each other no matter what answers they bring to each other. Okay, how many of you had a chance to go to the ramp center yesterday and experiment with rolling a big sphere and a little sphere? Okay, now if you have an idea of how they are different, I want you to tell me, and I'm going to write down. They reflect back to what they'd done earlier,
and they become more focused in what they're trying to figure out.
Danton?
The same.
You think they're the same? Okay, let's write that sound. They are the same. Is that what you want to write? They are, what two letters make the R sound?
E-R.
A-R.
You will find that I will often record misconceptions, but the children are very respectful in addressing those misconceptions with each other. They'll use words like, I disagree.
Okay. Now some of you are saying you disagree, you have a different idea, but I would like to know your explanation.
And then they'll explain the reason behind their disagreement.
Because it has more speed.
You have to follow the student's agenda. I have to give up my exploration and have to give it back to them and let them come up with their new problems. Because the whole process of experimentation is really what our goal is.
Constructivist teachers integrate all curriculum areas into RAMP's activities. RAMP structures are a form of architecture and sculpture that integrates artistic elements with the scientific relationships needed to make the RAMP work successfully. Children are also encouraged to make representational drawings of their ramps. This helps them to focus on the details of what they have done and share their ideas.
What I really would like you guys to do is to draw that ramp on paper, so the next time when you get ready to build it, you'll know how to do that. When you work with ramps, until you get it just the way you want it, the mind is constantly going.
Ramps provide the content for a broad range of academic activities for all ages. In literacy, for example, ramps are used as a springboard for reading and writing.
In first grade, most often the students will write personal narratives. They call them bed to bed, what they did when they got up to the time they go to bed. Now, to try to get them writing in a different genre, physical knowledge activities offer an excellent opportunity for this. So I do a lot of modeling with them first. Like the vocabulary word of sphere comes into play. And I modeled the question using the question mark at the end.
Okay. Now the first one I'm going to talk about is how is rolling a big sphere different from rolling a small sphere? They are the same. Okay, see how I used a capital letter at the beginning, period at the end? No other capital letters.
And as I'm writing down what they're thinking about, they're helping me with parts of words like the ER sound or the consonant blend or the vowel sound.
Faster. Okay, if I write fast, what ending do I have to put on to make it say faster? ER.
A reciprocal thing that happens though with literature is often they encounter a word. For instance, today a child was reading a book and the word foundation was in the book and he had no idea what a foundation was. And I was able to use his experiences with the ramps to talk about how he built the foundation of a tall ramp and how it had to be sturdy and that the rest of the structure could build on top of it, but the very base of it was the foundation. And he understood completely and could transfer right away to what a foundation on a building would be.
Constructivist teachers encourage social interaction among children. Just as children act on objects to gain knowledge of the physical world, children also construct knowledge about the social world using a similar process. They act on people through attempts to communicate, to negotiate, and to work together on a joint activity.
Another one?
Ready? Yeah. Hold on, no.
That was nice of you to ask was we ready yet, because then you know that it was okay to begin.
In the course of social interactions, children observe others' reactions to how they treat one another. Ramps and pathways provide children with many opportunities to interact and construct knowledge about social relations. Ramps and pathways activities are so engaging for children that interest will be sustained over long periods of time.
Oh, it worked!
Children need ample time and opportunities to experiment with ramps. When ramps are accessible to children all year long, they will be challenged to think at higher levels of complexity. The richness of ramps and pathways activities provides many opportunities for children to construct countless mental relationships that enable them to reason in more powerful ways. Through their deep interest and continuous experimentation, children pose and solve problems, show confidence in expressing their ideas, grow in their ability to think, and become increasingly more intelligent.